And the very first thing we're going to do with 7.2 is they're going to do just like we did back in 7.1. They're going to give you a system that we're looking at. And for these systems, it's going to be 3 equations with 3 variables. And the very first thing they're going to do is they're going to do just like we did back in section 1, that they're going to give you a system and they're going to give you one, well, not an ordered pair because now we've got X, Y, and Z, ordered triple. They're going to give you one ordered triple and ask you, is this thing a solution to the system? Okay, so with that ordered triple, same thing we were doing before. Now, this time you've got to plug it into all 3 equations. So for this one, we're definitely going to go back and put E1, E2, and E3, because there's not just a top and a bottom, and we wouldn't say top, bottom, and middle, but we're basically going to go back and check this and plug it back into all the different equations. And again, if all 3 are true, then it's a true solution. If any one of them is false, that's as much as you've got to do, and then just stop from there. Okay, so equation 1, if you plug it in, it's 2 plus 1 plus negative 3. Does that equal, oh, sorry, got my signs wrong. Hold on. 2 plus negative 1 plus 3. And again, the question is, does that equal 4? If it's yes, we go on to equation 2. If it's not, then we're done. 2 plus negative 1 is 1. 1 plus 3 does equal 4. So yes, that one is true. Okay. And once that one's true, we're going on to equation 2. We're going to check it out. So for equation 2, it's going to be 2 minus 2 times negative 1 minus 3. Again, the question is, does that equal 1? Well, that's 2 plus 2 minus 3, just 4 minus 3 equal 1. Yes, it does. So far that one's true. So then we're on to equation 3. And with equation 3, it's 2 times 2 minus negative 1 minus 2 times 3. Does that equal negative 1? So that's 4 plus 1 minus 6. Does 5 minus 6 equal negative 1? And it does. Okay, so all 3 of them were true statements, and if all 3 are true and they ask you, is that a solution, then yes, that is a solution to it. All right, let's give you one more of these. And sometimes it doesn't pop up much, but every now and again you'll have some systems that'll look a little bit different. So we'll go x minus 2y. They'll skip the z and have it equal 2. And then maybe same thing on the next one. We'll do 2x plus 3y equals 11. And then y minus 4z equals negative 7. Okay. So same thing with this one. Go back and plug in the numbers and see what happens. So we'll go back to equation 1. So plugging that in, that's 4 minus 2 times 1. Does that equal 2? No, that's 4 minus 2 equals 2. That is a true statement. Okay, check it for equation 2. That's going to be 2 times 4 plus 3 times 1. Does that equal 11? No, that's 8 plus 3 does equal 11, so that one's also true. Okay, last one, equation 3. That's going to be 1 minus 4 times negative 2. Does that equal negative 7? That's 1 plus 8 equal negative 7. That one is false. And again, as soon as that one checks off false, they ask you, is that a solution? It just takes one. Doesn't matter if it's the first one or the second or third. And as soon as you hit a false statement on that equation, then it's a false. It's done. It's not a solution. Okay, so here's what we're going to do for the next part. They give you those couple ones to warm up just to check for solutions. And then after that, they're just going to give you a system and say, all right, here you go. You're going to solve it. And what you're going to do, we'll give you a couple of steps for this thing. So if you have 3 equations with 3 variables, got to add a little bit more to it than what we were doing last time with just a 2x2 system. It's more of a 3x3 system. Now, in this case, none of the problems I've ever seen have been this way. I mean, you could get this way, but all the problems that we're going to do should be this part. That everything now should pretty much be lined up. You'll have your X's and your Y's and your Z's. Occasionally, if you have one like this problem, sometimes you might have to line this one up, because sometimes a problem like this one, they may put the Y and then the 4Z here, and then just have this blank so it's all crammed together. So you might have to line it up, space it out just a little bit. But for the most part, everything that you're going to have, it should even be lined up so that everything's pretty much there. So you don't have to worry about lining anything up. So here's what we're going to do. We're going to eliminate one variable by the addition method. With 2 equations. So same thing we were doing last time. You look at your lineup, you figure out which variable you think would be the easiest one to eliminate. Go back and, if you have to multiply or whatever you need to do that part to get there. All right, here's step 2. Here's the big one that you have to get that sometimes people forget about. You've got to eliminate the same variable using a different 2 equations, or using a different pair of equations. I'll say it that way. Now, because there's only 3 equations, you may say, well, if I'm using 1 and 2, how can I use a different pair? Because if I pick 3, then I've got to either pick 2 or 1. Well, that's the thing about it. You're going to repeat one of the equations, whether if you pick 1 and 2 to eliminate the first time, You're either going to have to pick 1 and 3 the next time, or you're going to have to pick 2 and 3, because you got to use a different equation. But it'll be just a different pair. So you may use 1 and 3 the first time, and then 2 and 3 the second time. But the key thing on that one is, it has to be the same variable, because usually the biggest thing that obviously the people will make mistake on is they'll take the first step and eliminate X, and then they'll go, oh, well, Y is really easy to eliminate this one, and I'll do this. And they get to the next part and they go, that's not right. And I'm like, no, it's not, because you got to do the same thing twice, basically. Okay, once you do that, then you should have it so that you've got, let's say you eliminated Z on the first step and Z on the second step. Now you've got 2 new equations that just have X and Y. So you're going to take those 2 equations and solve those by either elimination or substitution, just like you were doing in section 1. So we're going to take the equation from step 1 and the equation from step 2, and solve that system by either addition or substitution. And again, it doesn't matter which one you pick here. Most people are going to stick with addition just because most people like it better than substitution, because there's less rearranging and reordering and stuff that you have. Okay, so step 3 basically is the same thing we did from section 7.1. Okay, so basically from that part, and again, we'll just say that we eliminated Z from equations 1 and, or from steps 1 and steps 2. If we take this equation, step 3 here, we're going to solve this, we're going to get an X and Y answer. Once you get the X and Y answer, you're going to take those 2 variables, go back to any of the original 3x3s that we had, plug those in to find the last remaining variable. Or substitute the value of the variables, sorry. Okay, so once you've done the, and again, really it's basically 3 steps, and that third step is a big one because it's going to make you do everything back from section 7.1. But it's just solving, eliminating, and once you keep eliminating, you just keep eliminating, and once you get those first two values, just like we did in 7.1, you take those 2 values, go back to the original problem, pick any one of the 3 that's there, it doesn't matter, and figure out what that last remaining variable would be that you're going to have. Okay, so there's really not a whole lot new to it. It's just, it's a little bit longer because there's 3 parts to it, and we're just going to practice, you know, until y'all feel good with it. Okay, here we go. So here's the first one we'll do. Let's do x plus y plus 2z equals 11. X plus y plus 3z equals 14. And x plus 2y minus z equals 5. Okay, again, just for a good marker, we'll go back and put E1, E2, and E3 out beside it because it's a lot easier to keep up with it that way. Okay, now here's the thing. There's no wrong variable to eliminate first. You can pick any one you want to pick. It does not matter whether you get rid of X or Y or Z. It does not matter. You just have to figure out which one you think is going to be easiest to do twice. And the least amount of multiplying that you have to do, usually it's the better. So I would say, now in this case, you've got, again, if you look at it this way, you've got 1x and 1x and 1x. These numbers are all the same, so I'm thinking X would be the best thing to do. The Y's wouldn't be too bad. Even the Z's aren't too bad because all the numbers are pretty small and they all work out pretty well. But for this one, because all the X's are 1s, and you may want to go back and put 1s in front of these just so that you don't forget anything, I would say let's eliminate X twice. And it, I hate to say that it might be good just to write that statement down, but sometimes if you'll say it and then you do it, sometimes it kind of helps with that part of it. Okay, so if we're going to eliminate X twice, let's take equation 1 and equation 2. Now, they're both positive, so you've got to pick, doesn't matter which one, multiply one of them by -1. I'm going to pick the second one just so the negative's on the bottom. Doesn't matter which one you pick, but just pick one and go with it. Okay, so if we do that, we've got 1x plus. So I'm going to go ahead and put the 1s in here, just so we don't leave anything out, make any simple mistakes. 1x plus 1y plus 2z equals 11. We're going to take the second equation, multiply everything by -1. So that's -1x minus 1y minus 3z equals -14. Okay, and again, the whole thing we're trying to do is we're trying to eliminate X twice. Now in this case, we'll get a little bit of bonus on this one because we're going to do X minus X. That's going to make that go to 0, so the X is gone. We're also going to get this Y that also drops out, so that one's 0, so that one's gone. So in this case, it kind of works out kind of nice, and it doesn't. And sometimes it'll happen that way. That when you start eliminating variables, you get one answer almost right off the bat. In this case, we get a -z is equal to -3. If you want to put the 1 there, no problem doing that. So to solve for z, just divide both sides by -1, so your z value is 3. Okay, now we got lucky that we got rid of x and y at the same time. The next one we're going to do, it's not going to work out that way. That when we solve to get rid of x, we're going to get rid of x, but then we're still going to have a y and a z left over, so then that'll put us back more in the situation. So there's the first time. All right, so the second time. We've either got to use 1 and 3 or we've got to use 2 and 3. Doesn't matter which one. For this one, since we've already taken equation 2 and multiplied it by -1, and we've got to do the same thing again, let's just do equation 3. And then we're going to do that plus equation 2, but we're also going to multiply it by -1. Because if we've already done it once, let's don't reinvent the wheel here. Let's just, we've already multiplied that equation by -1. Let's just do it again. Okay, so equation 3 was 1x plus 2y minus 1z equals 5. And equation 2 times -1 was what we had in red, so we'll do it right again. -1x minus 1y minus 3z equals -14. Okay, and again, this one we're not going to get rid of x and y twice. This time we're going to have an x. The x will be gone because that's 0, and that's what we wanted. We're going to have 1y minus 4z equals -9. Okay, and once you get those two equations where you've gotten rid of the x, that's the two equations that you would solve basically like a system back like we did in 7.1. So we're going to bring both of these down and basically make a new system. It's only 2 by 2. So we're going to have, and it doesn't matter where you put them, we've got z equals 3 for this one, and we've got 1y minus 4z equals -9. Negative there. for this one. Now, here's where the good comes in, that we had that one answer that was just, because you've already got one of the variables. We got to find x, y, and z. We've already got z right here, and by having that z value, well, we just have to take the z value and plug it in right here. Because we know that z is 3. Well, now that we've got y and z, we can plug it in here to figure out what the y value is going to be. So that's going to be y minus 4 times 3 equals -9. So y minus 12, add 12 to both sides. We get y equals 3. Okay, and in section 1, once we had the 2 values, we were done. But in section 2, now you got to find 3 values. So we're going to go back and take the z value of 3, and also the y value of 3. And we're going to take those 2 values and plug those into any of the originals. To find out what x is. Okay, and again, it doesn't matter which one you pick. They're all pretty straightforward, pretty easy. Equation 1 looks just as good as the rest of them, so we'll go back to equation 1 here. So we'll go x plus y plus 2z equals 11. Okay, but we're going to plug in 3 for z and 3 for x. So that's x plus 3 for y and also 3 for z. So that's x plus 3 plus 6. Or x plus 9 equals 11, so x equals 2. Okay, and if they go ordered triple, x is first, y is second, and z is third. So if the two equation system was the Gemini project, because you had 2 people going up in the, and this is the Apollo. This is the big one, because now you got 3 that's going up, right? Takes a little more work, a little more power to get there, but it's it's the same process, just a little bit bigger, a little bit more complicated to get there. All right, let's get another. Everybody okay with that? Does it seem like it's okay? All right, let's get another one. See if we can get one that's just a little bit different here. So this one will go 4x minus y plus 2z equals 11. We'll go x plus y. Sorry, x plus 2y minus z equals -1. 2x plus 2y minus 2z equals, 3z. -1. Okay, and with the 2x2s, the signs are important. 3x3, it's just a bigger version. So this is one I'd say that, if you're going to write these out and take your time, go back and double check. And I'm going to do the same thing here, that all the numbers and all the signs are correct, because there's nothing worse than missing one sign, working through a problem and getting to the end, and the answer is like 1.976 and 2.413, and you go, that's not the way it's supposed to be. Because all the answers should be whole numbers. You shouldn't get any. You might get one fraction that's might be a half, but you shouldn't have all kinds of weird numbers when you're looking at these. Okay, so those are equations 1, 2, and 3. Okay, so this one, there's, again, kind of like the last one. Now, let's don't pick x this one because we picked to eliminate x on the last one. Let's pick y or z for this part, just so we can kind of do something a little bit different here. So which one do you want to get rid of? Do you want to get rid of y or do you want to get rid of z? Z? Okay. And again, there's no right or wrong way for this one, so we're going to eliminate z twice. Okay, so the first time, and because this is just a 1z here, we're going to take, I would say we're going to take equation 2, multiply it by 2, so we get a positive 2 to a negative 2. So for this one, let's back it up here. So we're going to take equation 1, add that to equation 2, and to make it work out, we're going to take equation 2 and multiply it by 2. So we get positive 2z and a negative 2z. And if it helps on these, go back and put 1s on any variables that's by itself. We put the 1 there. But that'll be alright. Alright, so equation 1. We're not doing anything to it. Equation 2, we're going to double everything. That's going to be 2x plus 4y minus 2z equals negative 2. Put those together. Alright, so it makes 6x plus 3y equals 9. Good. And again, z's gone the first time, so we're good there. Now, here's one thing that you can do, and sometimes it's about a 50-50 whether or not it's good for you. If you notice all these are multiples of 3, you could take all these numbers that's here and divide them all by 3 and make it 2, and we'll put over on the side over here because sometimes it's helpful, sometimes it's not, sometimes it kind of works its way out. But because they're all multiples of 3, you can also take this and make it 2x plus 1y equals 3. Now, and again, we're going to kind of hold on to that one because sometimes we do that and we get to the end and we're going to need 3y and negative 3y, and we may just kind of shoot ourselves in the foot because we go back and divide it by 3, and then we may solve this second time we solve for z, we may come back and already have a negative 3y, and we've got what we need. But we'll just kind of put this on hold because it might be easier to work with that one, or maybe not. So, if you say you want multiples, you can always do that. You can divide out whatever the multiple is, and it's about a 50-50. Sometimes it helps and sometimes it doesn't. Okay, so we eliminated z the first time. We've got to eliminate z again. So for this one, 1 and 3, right? That's going to be the easier bet to go with. So for this one, equation 2 and 3, I would say when we're going to multiply this by 3, but since both of them are negative, let's make this a negative 3. So we're going to take equation 2, multiply it by negative 3. And we're going to add that to equation 3. What we said? Yeah. Okay. So multiplying everything by negative 3. That's going to get us negative 3x minus 6y plus 3z equals 3. And double check my math here real quick. Equation 2 times negative 3. Negative 3x minus 6y plus 3z positive 3. Okay. In equation 3, we're not changing it, so that one will stay at 2x plus 2y minus 3z equals negative 1. Okay, so 3 minus 2 is negative 1. I'm going to go ahead and put the negative 1 on there just so we don't mess anything up when we're moving through the next part. Negative 6 plus 2 is negative 4. The z's go out, and then 3 minus 1 is 2. Okay, now here's where, again, you have to kind of look at it, that we've got these two equations, and now we've got to eliminate either x or y. And here we could do 6, and we've got 6x plus 3y equals 9. But this might be a little bit easier because now the numbers are smaller, because now we're doing 2 and negative 1, and we're doing 1 and negative 4, which should make it match up a little bit easier. So let's take this equation and bring it down, and we'll take this equation and bring it down. So those two, and I'm at the page. So and what was the second equation? Plus 4y plus 2. Is that right? Minus 4y. Okay. All right, so that's our two equations. Is that right? Negative 1x minus 4y. 2, 1, 3, negative 1, negative 4, 2. Okay. Okay, so which one? X or Y now? Because it's about the same either way. It's not really that either one of those two is harder. Yeah, I think so. Let's take the bottom equation here and multiply it by 2 so that we got a negative 2x, a negative 8y, and a 4. And the top equation, we're going to leave it just like it is. Okay, x is gone. We've got a negative 7y equals 7. So y is negative 1. Okay, and there's our first value that we found. Now again, we've got to get all three, so what we're going to do next is we're going to take that y equals negative 1 and plug it back into this 2 by 2 system that we've got here. I say let's just go with that first equation that's up here. So we're going to plug this into, again, take your pick, either one of these two equations back up here. 2x plus 1y equals 3. So 2x plus 1 times negative 1 equals 3. Or 2x minus 1 equals 3. Add the 1 to both sides. We got 2x equals 4. X equals 2. Okay, value number 2. And now we're going to take those two answers for x and y, pick any one of the originals, and plug in those two values. Let's see which one we get there. And again, it doesn't really matter, just the one you think would be the easiest. Maybe the second one, the one in the middle. So we go x plus y. X plus 2y. Minus z equals negative 1. Plugging those two numbers in, we've got a 2 for the x, negative 1 for the y, and that'll help us find out what the z value is. That is 2 minus z equals negative 1. 2 minus 2 cancels out, so that's negative z equals negative 1, so z is 1. Okay, so order triple-wise, which is probably what they're going to ask for. X is 2, the y was negative 1, and the z was 1, and there's our order triple right there. So x plus y equals negative 4. y minus z equals 1, and then 2x plus y plus 3z equals negative 21. Okay, now, even though it's funky looking, because you've got a couple of variables that's missing, we're missing x out of equation 2 and you're missing the z out of equation 1. It's still the same setup. You're still going to pick one variable to eliminate from both equations and go from there. Now, here's the thing, though. By them having the missing variables, they've done step 1 for you. So here's what I would do in this situation where they're doing this. Because x is missing here, this is where they've done step 1 if you want to eliminate x again. So now step 2 is you eliminate x from these two, take those two equations and go with it. Or you could, since they've eliminated z here, that's your equation you'd use for step 1. Then you eliminate z here, that's step 2, and now you've got step 1 and step 2 done. So when they give you one of these spots where the variables are missing, that means they've done step 1 for you. So now it comes down, do you want to get rid of x or do you want to get rid of z? Z, because the sign's already different, right? You don't have to worry about changing signs, so I would say Z is probably the better pick from this one. Okay, so step 1 is done for you. With x plus y equals negative 4. So Z is already eliminated. Again, it doesn't matter whether you pick the x or the z in that case. They've done step 1 for you with either one of those two, so then you just figure out that you want to go from there. So for step 2, well, we're just going to get rid of z right here. We're going to do equation 2 times 3, and then add that to equation 3. Okay, so again, we picked z this time. Now, you could still have done the same thing with y. You could have gone back and eliminated y twice, and it still would have worked out the same way. But just trying to get you the fastest work you can, if one of the variables is missing, that's basically step 1 that's done for you. Now you take the remaining two remaining two equations and eliminate that same variable that's here. So since this one's gone, that's what we're doing here. Okay, so equation 2 times 3. It's going to make that 3y minus 3z equals 3. In equation 3, we're not changing it, it's 2x. Plus, again, if you want to put a 1 there, just to make sure you don't forget anything with it, negative 21. Okay, so putting that together, nothing with the x, so it's just going to be a 2x. 3 plus 1 is a 4y. The z is gone, and then 3 minus 21 is a negative 18. Okay, so now we're going to take those two equations and bring them down and make that one system that we're going to work with. So x plus y equals negative 4. And then 2x plus 4y equals negative 18. So now that we're down to a 2 by 2, now it's just like 7.1. And it's about the same either way. Do you want to get rid of x or do you want to get rid of y? Okay, so if we get rid of x, let's take this first equation, multiply it by negative 2, and then we'll add that to the second equation in that system. Okay, so multiplying by negative 2, that's a negative 2x minus 2y equals now a positive 8. Second equation, we're not going to change it at all. So the x's drop out. 2y equals negative 10. So y would be negative 5. Okay, so there's our first solution. Okay, and since this came out of this 2 by 2, now we're going to take that -5 and plug it back into either one of these two equations to find out what the x value would be. And just because we don't have to multiply, I'd say let's go with the first equation, because you've got x plus y equals -4. So that's going to give us x plus -5 or x minus 5 equals -4. And then we're going to add that 5 to both sides. So x would be 1. And bottom of the page, so we're going to take both of those numbers over here, go back and plug it in. So then we're going to use x equals 1 and y equals -5. Plug it back in and see what we can get from there. Looking for z. So I would say from that one probably, well, if you're looking for z, it's got to be either equation 2 or 3 because there's no z in equation 1. So the one that's the easiest, I think, would be y minus z equals 1. Because you could go into the equation 3, but then you got to worry about x. In this case, it's just y and z. So this one comes out pretty straightforward because the y is -5. There is no x in this equation, so you don't have to worry about the x. So then we'll add 5 to both sides. Negative z is equal to 6, which means z is going to be -6. Okay, and there's our 3 solutions. And again, if we go for order triple, 1, -5, and -6.